I am Radhakrishna, mathematics teacher. Today we are going to have the last lecture in definite integration, only problem solving. The first question is integral minus 3 to plus 3 x power 8 into fractional part of x cube dx. Here, when the limits are minus a and plus a, we should check whether the function is even or odd. X power 8 is even, but fractional part of x cube is neither even nor odd. So, what we will do? We will use the property that x can be replaced by a plus b minus x. What is a plus b minus x? Minus x. So, replacing x by minus x, integral remains same. You take the given integral as I is equal to integral minus 3 to 3 x power 8 into fractional part of x cube dx, replacing x by minus x, integral minus 3 to 3 x power 8 remains as it is, and minus x whole cube is minus x cube. Okay. Now, let us add these two integrals. 2I is equal to integral minus 3 to 3 adding these two, x power 8 is common, x power 8 into fractional part of x cube plus fractional part of minus x cube. Now, what is fractional part of x plus fractional part of minus x for any real number x? It is going to be 1. For any real number, this is going to be 1, but except for integers. For if x is an integer, fractional part is 0, then fractional part of minus x is also 0, then it is going to be 0. If x is not an integer, if x does not belong to Z, the set of integers, it is 1. If x belongs to Z, it is 0. Here, integers are there only at minus 2, minus 1, 0, 1, 2. There are finite number of integers in this interval. At finite number of points, it is differently, this is equal to 0. At remaining all points, it is 1. Continuously it is 1 from minus 3 to minus 2, again from minus 2 to minus 1 and so on. So, we will take the first case only. Even if it is differently defined for some particular finite number of values of x, we do not mind, we can ignore. So, we will take this sum as 1, then you will get integral minus 3 to plus 3 x power 8 dx. Now, this function is even, so we can write this as 2 integral 0 to 3 x power 8 dx. So, 2 cancels, we get I is equal to integral 0 to 3 x power 8 dx. Integrate it, integral of x power 8 is x power 9 by 9. Substituting the limits, 3 power 9 by 9, 3 power 9 by 3 square is 3 power 7, that is the answer. Substituting the lower limit, it is 0 only. Next question. Integral 0 to infinity x tan inverse x by 1 plus x square whole square dx. Options are also given. We discussed some points that when the limits are 0 to infinity, there are two methods. sometimes we substitute x is equal to 1 by t, sometimes we substitute x is equal to tan theta. So, let us try one of them. If you put x is equal to tan theta, x is equal to tan theta means tan inverse x is equal to theta. Okay. So, I will substitute tan inverse x is equal to theta, theta or t. Then its derivative is 1 by 1 plus x square dx is equal to d theta. What are the limits? If x is tending to 0, theta tends to what? If x tends to 0, theta tends to 0. If x tends to infinity, what is the limit of tan inverse infinity? It is pi by 2. Theta tends to pi by 2. So, after getting the new limits, let us calculate the integral. Given integral is I. I is equal to, new limits are 0 to pi by 2. X tan inverse x. Tan inverse x is theta, x is tan theta. So, theta tan theta by 1 plus tan square, 1 plus x square whole square is there. 1 by 1 plus x square into dx becomes dt, but another 1 plus x square is present. That 1 plus x square becomes 1 plus tan square theta. Here x is tan theta now. So, 1 plus x square will be 1 plus tan square theta secant square theta into d theta. Now, how to integrate it? If we simplify, it becomes integral 0 to pi by 2 theta into, if you write this as sin theta by cos theta, then you will get sin theta cos theta. Sin theta cos theta is sin 2 theta by 2. So, we will solve on the next page. Integral 0 to pi by 2 theta into sin 2 theta by 2 means I will write 1 by 2 before the integral. Now, how to calculate its value? Integration by parts. But before that, let us try some property. Substituting pi by 2 minus theta in place of theta, you are getting the same function. So, you can remove this theta and multiply by upper limit by 2. So, it becomes pi by 8 integral 0 to pi by 2 sin 2 theta d theta. We have the property now. The property is integral 0 to a x f of x dx is equal to a by 2 integral 0 to a f of x dx. This is a formula only if f of a minus x is equal to f of x, not always. So, I applied that formula and eliminated theta. Now, what is the integral of sin 2 theta? It is minus cos 2 theta by 2. Substituting limits pi by 8 into, substituting pi by 2, how much you will get? Minus cos pi by 2, that is 1 by 2. Minus substituting 0, you will get minus 1 by 2. So, minus of minus 1 by 2 plus 1 by 2. So, finally, you are getting pi by 8. I is equal to pi by 8. Answer is fourth option. Okay. Let us proceed to the next question. Integral 0 to pi by 2 sin x plus cos x into root over e power x by sin x. Usually we solve many problems in different integration by using properties, but sometimes a question will be given in which you have to integrate in the normal indefinite integration method and then substitute the limits. So, if you try to apply the property, you will be wasting the time. So, this is one question of that type where property is not useful. Substituting pi by 2 minus theta, you are getting e power pi by 2 minus, substituting pi by 2 minus x, this remains same, and sin x becomes cos x, this becomes e power pi by 2 minus x, no use, you can't manipulate. So, we have to integrate in the normal method, in indefinite integration method. Let us separate into two integrals. First integral 0 to pi by 2, if you multiply sin x and root over e power x by sin x, what you will get? Root sin x cancels, you will get root over e power x into sin x plus, write the second integral, integral 0 to pi by 2 cos x into root over e power x by sin x. So, I will write root e power x into cos x by root sin x. Okay. Now, when there are two integrals, when the question is given as sum of two integrals, what to do? You do not need to calculate both, you calculate one of them, automatically the other will be eliminated, or then if it is not eliminated, you combine with this. So, let us calculate this part, because we know the integral of cos x by root sin x, so we can integrate by parts. It is a product of two dissimilar functions, exponential and trigonometric. So, we have to apply integration by parts only. So, I am taking the second integral, writing the first integral as it is. In the second integral, integrate by parts. First function is e power root over e power x. Second function is cos x by root sin x, because cos x by root sin x is in the form of f dash x by root f x, which integral is 2 root f x. We know the integral of the second function. So, first function into integral of the second function. What is the integral of cos x by root sin x? It is 2 root sin x minus integral derivative of the first function. What is the derivative of root e power x? Derivative of root x is 1 by 2 root x. So, you will write 1 by 2 root e power x and then multiply by the derivative of e power x into e power x into integral of the second function, that is 2 root sin x dx. Now, here we have to take limits 0 to pi by 2, here also 0 to pi by 2, bracket close. Now, this is as it is. Here you substitute the limits, 2 into substituting pi by 2, sin pi by 2 is 1, so it is 2 into 1 2, and this becomes root over e power pi by 2. Next, minus substituting 0, sin 0 is 0, so it is completely 0, minus plus into minus minus integral 0 to pi by 2. What is this? root e power x cancels, 2 cancels. So, remaining will be root e power x into sin x dx. See, you do not need to calculate this, it is cancelled. So, what is the answer? This is e power pi by 2 whole power 1 by 2 means e power 2 e power pi by 4. This is the answer. Next question. Let alpha and beta be two distinct roots of the equation tan x is equal to tan 2x. Then find the value of integral minus 1 to 1 sin alpha x into sin beta x dx. This looks very tough to get the idea, but this is the method is, once if you get the idea, method is very easy. First, how to integrate sin alpha x into sin beta x? Integral minus 1 to plus 1 here alpha and beta are constants, they are the roots of this equation tan x is equal to tan 2x. First, let us simplify the limits. Function is even now, replacing x by minus x we are getting the same function. So, applying the property of even function, you can write this as 2 integral 0 to 1 sin alpha x into sin beta x. Okay. Then how to integrate this? Multiplying by 2, then applying transformations. What is 2 sin A sin B? Cos A minus B minus cos A plus B. Integral 0 to 1 cos A minus cos A plus B, sorry, cos A minus B minus cos A plus B. A minus B is what? Alpha x minus beta x, that is alpha minus beta into x minus cos A plus B means alpha x plus beta x, that is alpha plus beta into x. Now, alpha minus beta and alpha plus beta are constants. What is the integral of cos alpha minus beta into x? Integral of cos x is sin x. So, integral of this is sin of alpha minus beta into x by alpha minus beta. Minus, what is the integral of this? Sin alpha plus beta into x by alpha plus beta between limits 0 and 1. Substituting 1, you will get sin alpha minus beta by alpha minus beta minus sin alpha plus beta by alpha plus beta, and substituting the lower limit 0, both are 0, sin 0 is 0. So, both are 0. This is the value of this integral. But what is the use of this information? Alpha and beta are two distinct roots of tan x is equal to tan 2x. So, let us try. Alpha is a root of this equation. So, I can substitute alpha, x is equal to alpha, then I will get tan alpha is equal to 2 alpha. Similarly, beta is also a root of the equation. So, I can substitute beta. Tan beta is equal to 2 beta. Now, if you subtract tan alpha minus tan beta is equal to what? 2 into alpha minus beta. How can you write tan alpha minus tan beta? Sin alpha by cos alpha minus sin beta by cos beta is equal to 2 into alpha minus beta. Now, take LCM and simplify. LCM is cos alpha cos beta. What is the numerator? Sin alpha cos beta minus cos alpha sin beta, that will be sin alpha minus beta is equal to 2 into alpha minus beta. Now, the answer is this minus this. So, find sin alpha minus beta by alpha minus beta from this. I will write in the next page. Sin alpha minus beta by alpha minus beta is equal to what? 2 cos alpha cos beta. Now, we have calculated this. Now, taking this, if we add these two, tan alpha is equal to 2 alpha, tan beta is equal to 2 beta. Now, if we add tan alpha plus tan beta is equal to 2 into alpha plus beta, is it not? Then tan alpha is sin alpha by cos alpha plus sin beta by cos beta is equal to 2 into alpha plus beta. Now, if you take LCM, what you will get? Sin alpha cos beta plus sin cos alpha sin beta, sin alpha plus beta by cos alpha cos beta is equal to 2 into alpha plus beta. So, now the second term is sin alpha plus beta by alpha plus beta is equal to what? Cross multiplying, we get 2 cos alpha cos beta. Now, what is I? If the given integral is I is the difference of these two. What is the difference of these two? It is 0, both are equal. Therefore, I is equal to 0. The asked integral is 0. Now, next question. If for a greater than or equal to 2, integral 0 to infinity dx by a square plus x minus 1 by x whole square is equal to pi by 5050, then find a. This is given, we have to find a. When the limits are 0 and infinity, just now we discussed, either we have to put x is equal to 1 by t or x is equal to tan theta, and we have seen the one substitution x is equal to tan theta in the previous questions. Now, in this question, putting x is equal to tan theta, it is of no use. So, we will try the substitution x is equal to 1 by t. Putting x is equal to 1 by t, dx is equal to minus 1 by t square dt. And what are the limits? New limits. If x tends to 0, Here actually 0 to infinity means it must be 0 plus, x is approaching 0 from right side. Then t tends to what? T is 1 by x, then t tends to infinity, is it not? Next, if x tends to infinity, upper limit, then t is 1 by x, so t tends to 0, 1 by infinity tends to 0. So now what is this integral? Given integral is I. New limits are infinity to 0. Dx is minus 1 by t square dt by a square plus, what is this? If you replace x by 1 by t minus t whole square, it is same as t minus 1 by t whole square. So I will write t minus 1 by t whole square. Now I can change t to x without changing the limits, and at the same time remove this minus sign and interchange the limits. So I can write integral 0 to infinity, I am going to change the variable t to x. It will be 1 by x square dx by a square plus x minus 1 by x whole square. Now adding this integral and this integral, because denominator is same, 2I is equal to integral 0 to infinity, write the common denominator a square plus x minus 1 by x whole square. And what is the sum of the numerators? 1 plus 1 by x square. Dx. So what is the idea behind this manipulation? Now if you observe it, you can notice that derivative of x minus 1 by x is 1 plus 1 by x square, is it not? So now we put x minus 1 by x is equal to some z, then its derivative is 1 plus 1 by x square dx is equal to dz. Next, if x tends to 0, then z tends to what? X tends to 0 means 0 plus. 0 minus 1 by 0 plus, 1 by 0 plus is infinity. 0 minus 1 by 0 plus will be minus infinity. So z tends to minus infinity. Next, if x tends to infinity, then z tends to what? If x tends to infinity, infinity minus 1 by infinity is what? 1 by infinity tends to 0. So infinity minus 1 by infinity is infinity. Now after finding the new limits, take this, what are the limits? Minus infinity to plus infinity, new limits. Numerator is dz, denominator is a square plus z square. Okay. Now what is the integral of 1 by a square plus z square? It will be 1 by a tan inverse z by a. We have to substitute the limits minus infinity to plus infinity. You will get pi 1 by a into, if you substitute infinity, what will you get? Tan inverse infinity tends to pi by 2 minus if you substitute minus infinity, tan inverse minus infinity tends to minus pi by 2. Then what is it? pi by 2 plus pi by 2 pi by a, but that is 2a. So, I is equal to pi by 2a, but it is given as 1 pi by 5050. It is equal to pi by 5050. Then what is the value of a? 2525. Okay. Next question. If I1 is equal to, integral 0 to pi by 2 cos of 2 pi by 3 into sin square x, I2 is equal to integral 0 to pi by 2 cos of pi by 3 sin x. Find I2 by I1. This is a very important model. Let us take I1 first. We have to express I1 in terms of I2 first. I1 is equal to integral 0 to pi by 2 cos 2 pi by 3 sin square x dx. What can you do? Try the property replacing x by pi by 2 minus x. Integral 0 to pi by 2 cos of 2 pi by 3 into sin square pi by 2 minus x will be cos square x. Okay. Then what will you do after applying this property? You will add the integrals. So, 2I1 is equal to integral 0 to pi by 2, integral 0 to pi by 2, this plus this is cos c plus cos d. What is cos c plus cos d? 2 cos c plus d by 2. What is c plus d by 2? If you add this and this, 2 pi by 3 into sin square x plus cos square x 1. Then c plus d by 2 is pi by 3 into cos c minus d by 2. 2 cos c plus d by 2 cos c minus d by 2. Cos c minus d by 2 is 2 pi by 3 into sin square x minus cos square x. Pi by 3 of cos pi by 3 is 1 by 2. So, this 2 and pi by 3 cos pi by 3 will cancel. Now, 2I1 is equal to, you know the formula, cos square x minus sin square x is cos 2x. Sin square x minus cos square x will be minus cos 2x. But cos of minus theta is cos theta, no? So, you can directly write this as cos 2x. Integral 0 to pi by 2 cos of 2 pi by 3, oh 1 minute, c plus c minus d by 2. By 2 we have not done, so 2 will cancel. 2 cos c plus d by 2 we have written, c minus d by 2. In c minus d by 2 we have not divided by 2. Okay. So, dividing by 2 it is pi by cos of pi by 3, only pi by 3 into cos 2x. Actually it is minus cos 2x, but cos of minus theta is cos theta, so I am writing plus. Now, what can you do? If we substitute here, we have to write it like this. For that, let us use f of kx property. What is f of kx property? You can, what is f of kx property? Integral a to b f of x dx is equal to, sorry, f of kx integral a to b f of kx dx is equal to integral ka to kb f of x dx into 1 by k. Here I am taking k as 2. This is f of 2x. So, it will be 1 by 2 into ka to kb is what? 0 to pi. 0 to pi cos of pi by 3 cos x dx. But I2 is cos of pi by 3 sin x dx. So, what to do? Replacing x by pi minus x, upper limit minus x, what are you getting? Cos pi minus x is minus cos x. But cos of minus x is cos x. So, function remains same. Replacing x by pi minus x, you will get minus sign inside, but cos of minus theta is cos theta. So, total function remains same. Then there is a property. What is that property? You can multiply the integral by 2 and divide the upper limit by 2. So, if you multiply by 2 and divide the upper limit by 2, cos of pi by 3 cos x. Now, use the property, replace x by pi by 2 minus x. What happens? Cos of pi by 2 minus x becomes sin x. 2 cancels, we will get integral 0 to pi by 2 cos of pi by 3 sin x dx, which is I2. It is I2. Therefore, what is the asked? I2 by I1. I2 by I1 will be equal to 2. Okay. Next question. If integral 0 to 1 tan inverse x by x dx is equal to k integral 0 to pi by 2 x by sin x dx, find k. Let us take LHS. Substitute tan inverse x is equal to t. Then x will be tan t, because derivative of tan inverse x is not there. So, that is why we are writing tan inverse x is equal to t as x is equal to tan t. Then differentiate, dx is equal to secant square t dt. And what are the new limits? I am writing directly. If x is 0, t is tan inverse 0, 0. If x is 1, tan inverse 1 is pi by 4. 0 to pi by 4, tan inverse x is t by x is tan t into dx is secant square t dt. Now, if you write secant square t in denominator, what you will get? Integral 0 to pi by 4 t by tan t into cos square t, that will be sin t cos t. Now, we have to convert this into the form of x by sin x. Now, multiply and divide by 2, then you will get integral 0 to pi by 4 2t by sin 2t. Then we can apply f of kx property, where k is 2. It will be equal to 1 by 2 integral, 1 by k means 1 by 2 integral ka to kb. So, multiply the limits by 2. 0 to pi by 4 into 2 becomes pi by 2. This becomes t by sin t, which can be written as 1 by 2 into integral 0 to pi by 2 x by sin x. We can change the variable directly. So, it is equal to RHS. So, what is the value of k? 1 by 2. K is 1 by 2. Next question. Integral 0 to infinity tan inverse x by root x into 1 plus x. What substitution will you try? X is equal to tan inverse x is equal to t means x is equal to tan t, then you will get root tan t here. So, let us not proceed with that. X is equal to 1 by t we will try. Put x is equal to 1 by t. Then dx is equal to minus 1 by t square dt. Take the given integral as I. I is integral 0 to infinity tan inverse x by root x into 1 plus x dx. Applying that substitution, what will be the new limits? If x tends to 0, t tends to infinity. If x tends to infinity, t tends to 0. You will get tan inverse 1 by t by 1 by root t into 1 plus 1 by t into what is dx minus 1 by t square. Into minus 1 by t square dt. Now, simplify taking LCM. First, remove that minus sign and interchange the limits. 0 to infinity, what will get t root t will go to numerator after cancelling t square. You will get root t tan inverse 1 by t, and we can write tan inverse 1 by t as cot inverse t. If x is positive, tan inverse 1 by x is cot inverse x. So, I will write tan inverse 1 by t as cot inverse t by, you will get t plus 1. I think root t, you will get root t in the denominator. Yes, you will get root t in the denominator, not in the numerator. You will get root t into t plus 1, right. Now, I can change the variable t to x. This is equal to integral 0 to infinity cot inverse x by root x into x plus 1 dx. Now, you will easily get the idea what to do next. Adding this I and this I, 2I will be equal to limits are same. So, write integral 0 to infinity, denominator is same, write the common denominator root x into x plus 1, and what is the sum of the numerators? Tan inverse x plus cot inverse x is pi by 2. So, numerator will be pi by 2 dx. Now, taking pi by 2 outside, dx by root x into x plus 1. Now, how to integrate it? Put root x is equal to t. then its derivative is 1 by 2 root x dx is equal to dt. So 1 by root x dx will be 2 dt. Now what will be the limits? 0 to infinity only. If x is 0, t is 0. If x is infinity, root infinity is infinity. Now dx will be 2 dt by 1 by root x dx will be 2 dt by x is t square. Root x is t means x is t square plus 1. Cancel this 2. What is integral 1 by t square plus 1? Tan inverse t, pi into tan inverse t between limits 0 and infinity. Taking infinity first, tan inverse infinity is pi by 2. Substituting 0, it is 0. Then you are getting pi square by 2. If 2i is pi square by 2, then I is pi square by 4. Okay. Next question. Here take n as a positive integer. Integral 0 to 1, 1 minus x power n power 1 by n minus 1 minus 1 minus 1 x power n minus 1 power 1 by n dx. In the beginning, we have discussed one formula, integral a to b f of x dx plus integral f of a to f of b f inverse x dx is what? B f of b minus a f of a. Okay. Now, if you take this function as f of x, if f of x is equal to 1 minus x power n whole power 1 by n minus 1, how will you get f inverse x? You take this as y, find x in terms of y, then interchange x and y. So, if you take this as y, then 1 minus x power n is equal to y power n minus 1, x power n is equal to 1 minus y power n minus 1, x is equal to, I am writing the same function, x is equal to this, the same given function f of x can be expressed like this, the relation between x and y. Now, if I want inverse function, I have to interchange x and y. So, interchanging x and y is equal to, you will get f inverse x will be equal to 1 minus x power n minus 1 power 1 by n. This is inverse function, it is the second part. Now, what is f of 0? F of 0 is equal to 1, putting x is equal to 0, and f of 1 is equal to 0. Okay. Now, separate the integrals. Integral 0 to 1, first one can be written as f of x dx minus integral 0 to 1 f inverse x dx, this is given, but here we want plus sign. f0 is f of 1, 1 is f of 0. So, I will write this as integral 0 to 1 f of x minus integral f of 1 to f of 0 f inverse x dx. Now, you can change this sign by interchanging the limits. you will get integral 0 to 1 f of x dx plus integral f of 0 to f of 1 f inverse x dx. It is exactly in this form. So, what is the value of this integral? B f of b means 1 into f of 1 minus a f of a means 0 into f of 0. What is f of 1? 0. Second term is also 0. So, it is 0 minus 0. Answer is 0. This integral is 0. Next question. F maps from R to R, f of x into f of x power 6 plus 1 is equal to x. Then find integral 0 to root 2 f inverse x dx. This is the functional relation between x and y. If y is equal to f of x, what is the given function? Y into y power 6 plus 1 is equal to x. This is the functional relation. Now, if I want inverse function, I have to interchange x and y. So, x is equal to x power 6 plus 1 is equal to y. This becomes f inverse x by interchanging x and y. So, f inverse x is x power 7 plus x. X power 7 plus x. Now, just integrate. Integral of x power 7 is x power 8 by 8. Next is x square by 2. Substitute the limits 0 to root 2. Substituting root 2, you will get 2 power 4. 2 power 4 is 16. 16 by 8, 2. Plus substituting root 2, what you will get? 2 by 2, 1. Substituting lower limit, it is 0. So, answer is 3. This integral is 3. Next question. Integral 0 to x f of t dt is equal to x square by 2 into x square by 2 plus integral x to 2 t square f of t dt. Then find f of x. In this kind of questions, we have to differentiate on both sides. By differentiating on both sides, we have to find f of x. Let us see. Differentiating on both sides. How to differentiate this different integral? Substitute the upper limit in place of t, then multiply by the derivative of upper limit. Derivative of x is 1 only, minus substitute lower limit and multiply by the derivative of lower limit. But lower limit is constant, so derivative of constant is 0. So, f of x minus 0 by differentiating LHS is equal to differentiate the RHS. Derivative of x square by 2 is x plus, if you substitute the upper limit and multiply by the derivative of the upper limit, you will get 0 minus substitute lower limit x, you will get x square into f of x and multiply by the derivative of x, that is 1. Then what are you getting? F of x is equal to x minus x square f of x. Then taking f of x this side, x square f of x this side, 1 plus x square f of x is equal to x, then f of x is x by 1 plus x square, that is all. Next question. If f of x is equal to x square plus integral 0 to x e power minus t into f of x minus t, then find f of x. What will you do? Just like previous question, we have to differentiate on both sides. But in the earlier question, this function is completely in terms of x, so we could differentiate. But here we have some, this integral is with respect to t and x is also there inside the integral. Okay. So, as long as x is there, we cannot differentiate directly. So, what we will do, let us apply property of definite integral here. F of x is equal to x square plus integral 0 to x. What is the property? We can replace t by upper limit minus t. That is what? E power minus of x minus t. And here also f of x minus of x minus t dt. Before differentiation, we have applied the property in the integral. What happens? This becomes e power minus x into e power t. Integral e power minus x into e power t. And what is this? F of t. Now, since we are integrating with respect to t, this e power x e power minus x can be taken out. X square plus e power minus x into integral 0 to x e power t into f of t dt. Now, we can differentiate on both sides. Differentiating with respect to x, what we will get in the LHS? F dash x is equal to 2x plus, how to differentiate? You have to apply product rule, u v dash plus u dash v. What is u? E power minus x into v dash. Differentiate this integral. What will you do? Replace t by upper limit and multiply by the derivative of upper limit. You will get e power x into f of x. Substituting upper limit and multiplying by derivative of x, that is 1. Lower limit is 0, so no need to subtract anything. This is u v dash plus u dash v. What is the derivative of e power minus x? It is minus e power minus x. Minus e power minus x into v as it is, integral 0 to x e power t into f of t dt. Now, observe it, e power minus x into e power x becomes 1. Now, I will write on the next page, f dash x is equal to 2x plus, this is f of x, next is minus of this. I can substitute the value of this, from the previous step. From the previous step, what is the value of this? F of x minus x square. So, here minus of, minus of f of x minus x square, understood? This is equal to f of x minus x square from the previous step. Now, f of x cancels, we get f dash x is equal to 2x plus x square. If f dash x is 2x plus x square, what is f of x? By integration, indefinite integration, you will get x square plus x cube by 3, indefinite integration, but plus c, we have to write constant of integration. Is it possible to find c? Let us try. Putting x is equal to 0, you will get 0 plus 0 plus c. So c is f of 0. What is f of 0? See this, 0 plus integral 0 to 0, that function. Integral 0 to 0, anything is 0. If this is 0 square, 0. So f of 0 is 0. Therefore c is equal to 0. Therefore the function is f of x is equal to x square plus x cube by 3. Okay. Next question. If f of x is equal to integral 0 to 4 e power mod x minus t dt, where x belongs to 0 to 4, find the minimum value of f of x. First let us calculate that function. Integral 0 to t, 0 to 4 e power mod x minus t. dt. We are integrating with respect to t. Let us break this integral at x. 0 to x and x to 4. X lies between 0 and 4. Okay. In the interval 0 to x, if you integrate, t lies between 0 and x. If t lies between 0 and x minus t is clearly positive. Is it not? So directly we can open the mod. It will be e power x minus t dt. Understood? T lies between 0 and x. So x is greater than t. So x is greater than t means mod x minus t is x minus t. Plus, in this interval, t lies between x and 4 when you are integrating. So t is greater than x. So what is mod of this? It will be t minus x dt. Now you can integrate. First take out e power x. E power x integral 0 to x e power minus t dt plus integral x to 4, you can write e power minus x outside, e power t dt. You can calculate this and get the minimum value. What is the integral? E power x into, what is the integral of e power minus t? Minus e power minus t 0 to x plus e power minus x into, its integral is e power t x to 4. Substituting x and 0, e power x into, you can write minus sign outside, e power minus x minus e power 0 1. Second, e power minus x into e power 4 minus e power x. This is minus 1, this into this, plus e power x plus e power x, e power minus x e power minus x into e power 4 minus 1. Okay. Now you will get e power x plus e power 4 by e power x minus 2. Now you can get the minimum value of this by AMGM relation. By AMGM relation, this is product is constant, no? So this plus this by 2. If you solve on the next page, e power x plus e power 4 by e power x by 2 is greater than or equal to, arithmetic mean is greater than or equal to, what is the geometric mean? Square root of e power x into e power 4 by e power x. What is it? E square. So, cross multiplying by 2, we get this is greater than or equal to 2e square. Is it not? Minus 2. So, that is the minimum value of f of x. Okay. So, with this we have completed definite integration, and now we are going to start the next topic. We are going to continue coordinate geometry, and that is with ellipse. Already we have completed up to parabola. So, we are going to start ellipse in the next class. Okay. Thanks for watching. See you tomorrow.